welcome to the fashionable film city Banauliwood film city. And again, I am a fact scientist, corner scientist, visiting in the Banauliwood film city. And today I am going to discuss the uh, two conservation phenomena like conservation of energy and conservation of mass uh, in terms of relativity. So let us start. First, see the conservation of mass plus energy. According to the given statement, the law of conservation of energy and the law of conservation of mass appear as completely independent of each other in classical mechanics. The present situation is, however, much different, that is, in relativity. In view of Einstein's mass energy equivalence principle, that is E equals to mc square, mass and energy were no longer independent entities. Mass itself is just one form of energy. It can be created or destroyed, provided an equivalent amount of energy simultaneously vanishes or comes into being, and vice versa. Hence, separate conservation principle of energy and mass are no longer justified. In fact, they have melted together into a single principle, which tells that the mass plus energy of the universe is constant, that is conserved. This is the principle of conservation of mass plus energy, that is conservation rule in relativity. Let's clear this with some example. So first see the mass energy conversions. The mass energy conversion factor is C square, where C equals to 3 into 10 to the power 10 centimeter per second in CGS unit, so that 1 gram of matter has an energy content of 9 into 10 to the power 20 erg. Even a minute bit of matter represents a vast amount of energy. Hence, mass energy conservation can be noticed in phenomena like nuclear reaction, in which the masses of the particles are quite small and high energies can be imparted to them. Let's see some examples related to mass energy conversion. Formation of nuclei. First, formation of nuclei. When protons and neutrons combine to form nucleus, the mass of the nucleus is less than the sum of the masses of all the protons and neutrons. The balance is released as energy in the form of gamma rays. For example, deuteron and for example, neutron and deuteron. Deuteron consists of neutron and a proton. Its mass is found to be 3.3433 3.3433 into 10 to the power minus 24 gram. But the mass of a neutron is 1.6748 into 10 to the power minus 24 gram. And that of a proton is 1.6725 into 10 to the power minus 24 gram. Their sum being 3.3473 into 10 to the power minus 24 gram. Thus, the mass of the deuteron is less than the sum of the masses of neutrons and protons by an amount given by delta m equals to 3.3473 into 10 to the power minus 24 minus 3.3433 into 10 to the power minus 24 equals to 0.0040 into 10 to the power minus 24 gram. This loss in the mass is equivalent to the energy as given by del E equals to delta m into c square, and using our value, that is 0.0040 into 10 to the power minus 24 gram into 3 into 10 to the power 10 to the whole square, we get 3.6 into 10 to the power minus 6 earth, which comes out, which is equivalent to the 2.25 into 10 to the power 4 electron volt, because 1 electron volt is equal to 1.6 into 10 to the power minus 12 erg. We find that when a neutron and a proton combine to form a deuteron, this amount, this amount, this amount change. Uh, we find that when a neutron and a proton combine to form a deuteron, this amount of energy is liberated as a gamma rays. Conversely, the same amount of energy must be added if the deuteron is to be, if deuteron is to be Neutron is to be split into proton and a neutron. This is called the binding energy of the nucleus. Second, artificial disintegration of nuclei. When the nucleus of lithium atom is struck by a proton, two alpha particles are produced and a huge amount of energy is released. And this reaction is given by L sub 3 sub 7 plus H sub 1 sub 1 changed to 2 H sub 3 sub 4 plus energy. Now the mass of a lithium nucleus is 11.6399 into 10 to the power minus 24 gram, and that of proton is 1.6725 into 10 to the power minus 24 gram. Thus the mass of the original system is 13.3124 into 10 to the power minus 24 gram. But the combined mass of two alpha particles is 3.3 3.3124 into 10 to the power minus 24 gram. But the combined mass of the two alpha particles is 3.2908 into 10 to the power minus 24 gram. Thus, the mass disappeared in this nuclear reaction is given by delta M equals to 13.3124 into 10 to the power minus 24 minus 13.2908 into 10 to the power minus 34 equals to 0.013 into 10 to the power minus 34 gram. This is equivalent in energy to delta E equals to delta M into C square. After calculating, we get 2.88 into 10 to the power minus 6 erg. This energy should be released in the reaction, which is in the excellent agreement with the experimental value as determined by measuring the range of alpha particles. Third example, a beautiful example of mass energy conversion is the process of hair production. In this process, an energetic gamma ray under proper condition is converted into an electron and a positron. Gamma changes to E sub minus plus E sub plus. The rest mass energy plus the kinetic energy of the pair of particles which appears is equal to the energy of the gamma radiation which disappears. The reverse process in which an electron and positron are converted into gamma radiation is also true and known as pair annihilation. So with this, I in this movie here, and I think you are enjoying this movie made in fashionable film city Banauliwood. Thank you very much for watching this.